Hey guys, we're going to jump into lesson 10.4. This is going to be our last lesson that's specifically talking about statistics. So we're going to be talking about comparing populations in this lesson. So to compare populations, a box plot uses a number line to show the distribution of a set of data. It divides a set of data into 4 parts using the median and quartiles. A box is drawn around the quartile values, and whiskers extend from each box to the minimum and the maximum values that are not outliers. A double box plot consists of 2 box plots graphed on the same number line. You can draw inferences about the 2 populations in a double box plot by comparing their centers and variability. Okay, so first thing we want to do, we've got our box and whisker plot down here. We want to label the different pieces of it. So all the way to the left, our lowest point here, that's going to be our minimum, which we usually just abbreviate min. Then this first line here, that is our Q1 or our quartile 1. This line in the middle is our median. Remember, median was the middle line, or the middle number rather. And then to the right of the median, finishing up our box part, is our Q3 or our quartile 3. And then the higher whisker is our maximum, which again we usually just abbreviate max. Now, down here, the width of the box, so from Q1 to Q3, if you remember back to previous lesson, we call this our interquartile range, or our IQR. So, make sure you guys can label this picture. You're going to see it a couple times this week. Know that the minimum's all the way on the left, then we see our Q1, median, Q3, our maximum, and then our IQR. Now, an important piece here, I started talking about it in a previous lesson. Each of these quartiles contain 25% of our data. Think about quartile, quarter's 25 cents. So if I asked you what percent of the data fell from your minimum to your median, well, I've got 25% and 25%, so that would be 50%. There's 50% of the data in the IQR. Notice, even just looking at this picture, none of the pieces are the same length, but it's where 25% of the data falls. If it's a shorter length, that would just mean that the data is more similar or much more closer together. If it's spread out, we would say that it has a high variability because we're going from a real low to a high with all the data spread out pretty evenly in between. Okay, so that's our introduction there, labeling our box and whisker. Again, make sure you guys can label this. You're going to be asked to do it a couple times this week. Okay, so we've got Casey surveyed a group of students in her science class and in her math class. The double box plot shows the results in both classes. Compare their centers and variations. Write an inference you can draw about the 2 populations. So this is what was being said on the previous slide, where we have the 1 number line but 2 box plots. So that's what we call a double box plot. We're using that same number line to compare the values. So this one is asking you to draw some inferences. So if we take a look here, one thing we notice, their ranges are the same. So I'm going to make that little note over here. So they have the same range. They both range from 0 to 30. So remember, we find our range by doing our maximum minus our minimum, so they'd have a range of 30. If we take a look at our medians, I see my science class median is all the way up at 20, where my math class median is only at 10. So for science class, over half the class is blogging more than 20 times a month, where our math class, half of it is 10 a month, or 10 or more a month, sorry about that. So one inference we can make is that in general, I misspelled that, sorry. The science class blogs more. And we know that because it has a higher median. Now, something else that we could talk about we see that the ranges are the same, but if we take a look at our IQRs, so for math, our IQR is going from 5 to 20, so we have an interquartile range of 15, where our science class is ranging from 15 to 25. So that's only a IQR of 10, so we could say that the math class has a higher variability. And again, we know that because it has a higher IQR. So those are just some of the inferences we could make. Looking at these, you're going to be asked specific questions about comparisons or percentages. We could say that 25% of the math class only blogged 5 times or fewer. We could say that 25% of the science class blogged 25 times or more. 50% of the science class blogged between 0 and 20 times. Throw some different percentages around. Or in this case, since we're talking about quartiles, our percentages are always going to be 0, 25, 50, 75, or 100. When we talk about our variability, typically we look at the overall range first, but since they both have the same range, we then look at the IQR to determine which one has a higher or lower variability. Again, you're going to be asked specific questions, so I just wanted to use this slide to introduce it, talk about some of the different things that you're going to see here. So moving on to see some of these specific questions. So looking at test scores for a first period versus a second period, the question is which period has a higher variability? So again, variability, we're looking at range first, so the overall range. And then if they happen to have the same overall range, then we look at and compare the IQR. So for my first period, we are ranging from a low of 60 to a high of, we'll say that's probably 97, versus second period is ranging from a low of 70 to a high of 95. So for first period, our overall range would be about 37. For second period, the overall range is only 25. So first period has a higher variability. And again, we know that because it has a higher range. So just to make a note up here. So first period range was about 37. Second period range was about 25. Okay, so, and then just to make sure, if we look at this, our IQR does actually match up with the overall range, where if you find your IQR for your first period, we're going from a 75 to a 90, so that would be an IQR of 15, where second period was from an 80 to, that looks like it's probably about an 81, so their IQR was only 11. So not a huge difference, but it's still showing a higher IQR, so a higher variability for that first period. Okay, so let's take a look at another question. What percent of the data is between 60 and 75 on the number line? So if I find my 60, that matches up with my minimum. My 75 matches up with my Q1. And if we remember back to here, we know that each one of these chunks accounts for 25% of the data. We're only looking at one piece, so just from the min to the Q1, so that is 25%. Again, keep in mind, it's not about what percent of the numbers are there. We can't see where our data points fall in between the min and the Q1, so we actually don't know how many data points are there, but we know that 25% of the data points are in that chunk right there. Okay, so comparing this one, which period had a higher median score? If we think back to that first grid, we know that the median is the line in the middle of our box. So it looks like second period has a higher median. The first period median looks to be about an 80. Second period median is an 85. Just going to clean up that 0 there so it doesn't look like a 6. So it looks like second period has a higher median. So as you guys can see, these are the type of questions you're going to be asked, either about a single box and whisker or a double box plot. So just being able to interpret what you're seeing. We're not going to really ask you to make your own inferences. We just want you to interpret what you're seeing. So the most important part is, again, going back to that first slide and making sure that you know all the different pieces of your box and whisker, and also making sure that you remember that each part accounts for 25% of the data. Okay, so true or false? 75% of the class scored between 70 and 85. All right, so let's find our 70 and our 85. So I just label these real quick. We have 25%, 25%, 25%. I know they're getting a little squished there. And 25% from our Mentor Q1. So from a 70 to an 85, I'm going from my minimum to my median, which accounts for 50% of my data. So this is false. A 70 to 85 is only 50% of the data. Okay, so I'm going to have you guys try one. So true or false, 25% of the class scored below an 80. So go ahead and take a look at this, come up with your answer, pause the video if you need to, and then come back. Okay, so if we go to our 80, draw a line there so I know exactly where it is. I want to go below. Make sure you guys are looking for the key word. So below means you're going to the left. So that accounts for this 25% only. So true or false, 25% of the class scored below an 80, that would be true. Again, since we're going to the left, that was only 25%. That's only one chunk. Each of these, so that's 25%, 25%, 25%, and our last 25%. So this one was true. Again, make sure you guys are looking out for keywords. If it had been above or between, most likely our answer would have been false, because we would have been going to the right. Okay, one more for you guys to try on your own. So which statement explains why it is reasonable to infer which restaurant has the greater variability in wait times? Okay, so go ahead, check out the double box and whisker here, comparing Lucy's Steakhouse and Gary's Grill, talking about average wait times. There are 4 options, and you're looking again for which one explains why it is reasonable to infer which restaurant has the greater variability in wait times. So go ahead and pause the video so you have enough time to really read through them, and then come back and we'll go over it together. Okay guys, so if we read through these, we have A, Gary's Grill, the range is greater. B, Lucy's Steakhouse, the interquartile range is greater. C, Lucy's Steakhouse, the median is greater. And D, Gary's Grill, the first quartile is greater. So again, going back, we want to decide which one of these is reasonable to infer which restaurant has the greater variability in wait time. So the first thing I want to do is go through each of these with you to decide which ones are true and which ones are false, and then we'll go from there. So for A, Gary's Grill, because the range is greater. If I look at my range, Gary is ranging from 0 to 35, so his range is 35. Lucy's is ranging from 5 to 45. So Lucy's range is 40. So is Gary's range greater? No, that's false. So if I look at B, Lucy's steakhouse, because the IQR is greater. Well, if I look at Lucy's, use a different color here so we see different ranges. So for Lucy's, her IQR, so her Q1 is going from 10 to her Q3 is 30. So Lucy's IQR is 20. Gary's, again, his Q1 is at 10. His Q3 is at 20, so his IQR is 10. So B was saying that Lucy's Steakhouse, because the IQR is greater. This is true. So that one's still in the running. For C, Lucy's Steakhouse, because the median is greater. Okay, so remember our medians are in the middle. So Lucy's median is at 20. Gary's median is at 15. So yes, Lucy's median is greater. So this is also true. And then for D, Gary's Grill, because the first quartile is greater. Okay, so Gary's first quartile is at 10. Lucy's first quartile is also at 10. So they're actually equal. His is not greater. Okay, so we ended up with two true statements. Only one of them is correct, though. Take away all these marks. So, Lucy's Steakhouse because the IQR is greater, or Lucy's Steakhouse because the median is greater. While they're both true statements, the median actually doesn't tell us anything about our variability. Remember that variability dealt with range. So between these two, the B would be the one that we want to pick because it's talking about the interquartile range. So again, while they are both true statements, the median doesn't tell us anything about our variability, so we would want to pick B. Okay, so last thing, you may recall that a line plot is a way to organize and represent the data in a data set. Another name for a line plot is a dot plot. A dot plot uses dots to show the frequency of data in a distribution. A double dot plot consists of two dot plots that are drawn on the same number line. Okay, so these are very similar. We're going to use them to compare. If we take a look at these, comparing the daily high temperatures between Springfield and Lake City. So first thing I'm going to look at is my range. So Springfield has a minimum of 78 and a maximum of 84. So they have a range of 6, going from 78 to 84. Lake City, we have a range of 81 to 87. So the range is also 6. They're both pretty evenly spread. So we would say they have the same variability. If we look, they're actually pretty much mirroring each other. We've got 3 dots in the middle and then 2 sets of 2 and 1 set of 1 at our minimum and our maximum. We can find our minimum and maximum on here. Whatever dot is to the lowest, that's your minimum. Whichever dot is to the right, furthest right, that's your maximum. We could actually find our median. We could find our mode. We could find our mean if we wanted to. So you could find all of your measures of center because these are all of your data points in this case. So one last thing we could maybe say here is that Lake City has higher temperatures. So again, just being able to look at the dot plots and interpret them, knowing where your min, your max, being able to find your median, you be asked specific questions again, not a lot of making inferences on your own. So, all right, this lesson was a little longer, so you guys won't have an exit ticket or a bell ringer for today. It's just the video and then the homework. As always, if any questions, please let me know.